A real-life Jarvis is not one giant model waiting beside a microphone. It is a pipeline with 6 jobs, and each job needs a failure boundary. The jobs are WakeWord, speech detection, speech recognition, intent or reasoning, tool execution, and spoken response. Home Assistant already documents a fully local version of this architecture. A microphone hears the command. A local speech engine turns audio into text. Home Assistant decides the intent. Piper generates the reply. The voice data can remain on hardware you control. Stage 1 is the WakeWord. openWakeWord listens for a short phrase such as "Hey Jarvis." It should be lightweight because it runs continuously. The full speech model should wake only after that trigger or a button press. Use case: hands-free control from a room microphone. Failure: TV dialog triggers the assistant. Control: show an audible or visible listening indicator and require a second confirmation for sensitive actions. Stage 2 is voice activity detection. The system needs to know when speech starts and ends. Stream too much silence and latency grows. Cut too early and the assistant receives "Please turn off the," which is a bold request with several possible victims. Stage 3 is speech to text. Home Assistant supports local options including whisper and speech to phrase. Whisper handles more open language but needs more compute. Speech to phrase is narrower and can be faster for home control phrases. Use case: say turn the office lights to 30% observable result. The transcript preserves office, lights, and 30% with word confidence or a reviewable text state. Stage 4 is intent. Deterministic home commands should prefer deterministic intent matching. Device names, areas, actions, and values can map into structured fields. Use a language model for open questions, follow-up reasoning, or requests that need flexible interpretation. Do not ask an LLM to invent a device identifier when Home Assistant already owns the device registry. The model can translate "dim the cave a little" into "area office, device lights, brightness 30." The tool layer validates that the area and action exist. Stage 5 is execution. Give the assistant narrow tools: read temperature, list lights, set brightness, start a timer. Separate read operations from state-changing operations. For unlock door, open garage, disable alarm, purchase, delete, or send require explicit confirmation. Repeat the exact action in target. Unlock the front door now. Do not accept yes 5 minutes later in a different conversation. Bind confirmation to the pending action and expire it. Stage 6 is speech output. Piper is designed for fast local text-to-speech and is optimized for modest hardware. Keep responses short. A voice assistant that reads its internal architecture after turning on a lamp will soon become a silent assistant by popular vote. Now assemble one complete interaction. The Wake model hears "Hey Jarvis." The indicator turns on. Voice activity detection captures one utterance. Speech recognition returns. Set the bedroom temperature to 22 degrees. The intent layer resolves bedroom and target temperature. The tool checks whether a thermostat exists, validates the allowed range, and identifies that changing temperature is permitted. Home Assistant applies the change and returns the actual new state. Piper says "bedroom set to 22 degrees." The reply comes from the tool result, not the model's assumption. Latency is the product. Measure wake detection, transcription, reasoning, tool execution, and speech generation separately. A small local language model may feel better than a larger one if it keeps the interaction under a few seconds. Use streaming where it is honest. Speech recognition can begin before the utterance ends. Text-to-speech can start after the first confirmed sentence. Do not speak success before the device reports success. Privacy needs a map. Record whether raw audio is stored, how long transcripts remain, whether an LLM provider is ever used, where logs live, and which tools can reach the network. Local speech plus cloud reasoning is a hybrid assistant, not fully local. Test the ugly cases. Play the WakeWord from a TV. Add music and distance. Use similar room names. Mispronounce a device. Disconnect the network. Make the tool timeout. Put a hostile instruction inside a web result. Ask for a dangerous action casually. The assistant should clarify ambiguity, stop on missing authority, and never convert silence into consent. Choose hardware by stage. A small always-on device can handle microphone capture and wake detection, while a home server handles whisper, intent, and Piper. Use the Wyoming or equivalent local protocol boundary, so voice satellites do not each need a full model stack. This also lets one faster machine serve several rooms. Keep a deterministic event bus between stages. Each interaction receives an identifier: wake, transcript, resolved intent, tool request, tool result, and spoken response attached to that identifier. If the bedroom light fails, the trace shows whether the microphone, recognizer, resolver, or device caused it. Add conversational state sparingly. The follow-up, make it brighter, can reuse the last confirmed device for a short window. It should not reuse a week-old target, display or speak the resolved object when ambiguity remains. Start small. 1 room, 5 tools, local wake word, local speech, local voice, and deterministic intents. Add an LLM only where flexible language creates measurable value. Give the first version a visible control panel. Show the live stage, resolve device, pending action, and confirmation timer. Add a physical mute control that disconnects capture rather than drawing a reassuring icon over an active microphone. Create a release test with recorded audio, background noise, false wake phrases, ambiguous commands, and tool failures. Replay the same set after every model or configuration change. Track false wakes per hour, missed commands, transcription errors on device names, end-to-end latency, wrong tool attempts, and confirmations correctly blocked. Finally, design graceful degradation. If the language model is unavailable, basic local intents should still turn on lights and set timers. If speech output fails, the screen should show the result. If device state cannot be confirmed, Jarvis must say it could not verify the action, not improvise success in a confident accent. That is the real Jarvis. Not a model with access to everything. A fast local voice pipeline whose authority stays smaller than its personality.